afternoon, good evening. Hello, everybody out there. Hello, everybody in there. Having to admit, a few more people. Welcome to you all. Glad that you're here. We've got a packed session tonight with research papers on learning, 4 of them, and on innovation, another 4 of them. So I do hear an echo from somewhere. So maybe if everybody could mute themselves, that certainly would help the sound quality of this session. Thank you. And without a lot of introduction, I'd like to ask Melvin to please and share the screen now. I guess I need Cindy to allow everyone to. Cindy, I made you a co-host.
Okay.
So if you could give sharing rights to everybody. We've got quite a tight schedule. So what I'll be doing, you've all got like 10 minutes to present, but in the last minute of your presentation, which I'll monitor with my little Swiss railway watch, which I've got here, I'll gonna fade in an underlying sound, which I guess you can start to hear in the very background. It should be there, and it's coming up, and it's getting harder, and it's exactly 1 minute, and at the end of it's a ticking clock that comes in, and at the end of that 1 minute, the ticking gets harder and gets faster. So you hear that you need to get into a time warp and wind up, and it will end with a few beautiful grandfather clock dongs.
Here, I cannot do anything with the screen sharing. I get host disabled participant screen sharing.
All right, so let me see what I can do. Anyway, I'd like to ask Melvin to start. So if I make you a co-host, Melvin, can you now share your screen? And I just try to make you co-host again, Cindy.
Yes, I'm not co-host. Now, Melvin, I think you should be able to share. Yes.
Melvin, we can't hear you.
Can you hear me now?
Yes.
Okay, sorry. I'm working from 2 things. So we try to stay away from the P through 16 lexicon as much as possible, but there's certain terms that we wanted to make sure that we're clear when we're talking about this. And one of these terms is epistemology, which is a branch of philosophy which is concerned with the nature and scope of knowledge. And from this vantage point, constructionism is the education philosophy, which casts students as critical, engaged, active participants in the co-construction of their knowledge. Constructionism starts with, Constructionism 1.0 starts with Seymour Papert and his colleagues at MIT when they gained National Science Foundation funding from the LOGO project, which is now considered K through 12 computer science education, the beginning of K through 12 education science. The key point around constructionism is that it was a personalized approach that served as an object to think with. The development of the turtle for Papert was used to be an object to think with, and he was very clear about the fact that these objects had to have a low floor, meaning that they're easy to access for every young child, and no ceiling or nearly limitless potential for complexity. One of the dilemmas that happened, and this happens throughout this story, classrooms' use of LOGO was more as a tutorial, and they didn't use it as the rich and powerful medium that it could be used for. And Papert coined the term epistemological dilution to describe the process. Another thing that happened with LOGO is that during the back to school movement in the United States and around the world, it became a standardized way of thinking about schools, and went back to basic. LOGO sort of died out. Constructionist 2.0 starts off where Mitch Resnick and his group at the Lifeguard Kindergarten Group, Papert Epistemology and Learning Group at the MIT lab formed the group together, and it was STAR logo, but the main thing was Scratch. And Scratch was launched in 2017 with a strong focus on creativity. And that's key to understand that he was really talking about creativity, not math and science, like LOGO was more around like math and science. And in his book, Lifelong Kindergarten Group, Resnick describes the popularity of Scratch to Seymour's advice on a low floor, high ceiling, with one important caveat, and that was the dimension of wide walls. And what he was saying was, it's not enough to provide a single pathway from low floor to high ceiling. It's also important to provide multiple pathways so that all children can enter and do personal meaningful projects where they want to come together. Another key thing that happened with Constructionist 2.0 with Scratch is the notion of the Web 2.0 online code editor feature. And this moved constructionism from 1.0 to 2.0 in that it had that distributive nature. And so it became objects to think with, and from objects to think with to objects to think with together. And so that was the second version. Then we came to 3.0, and Constructionism 3.0 originated at the Center for Bits and Atoms at MIT. And in the paper, we recall a scene where Papert and Neil are talking to each other, and Neil is saying that he thought the Fab Lab thing was just a historical accident. It's in his book, and I reference it in the paper. But Papert tells him that he points to his side, and he's pointing to his side like that's been a thorn in his side the whole time, that you could use the turtle to move it, or you can manipulate the turtle within the computer screen, but with digital fabrication tools, you can actually make the turtle. And so viewed this way, learning in the Fab Lab follows directly from the work that that Papert started decades ago. And Neil is quoted as saying, it's not an accident that there's a natural progression from going to MIT to play with a central computer, to going to the store to purchase and play with a toy containing a computer, to going into a Fab Lab to create the turtle yourself. So in that conversation, it became very clear that the Fab Labs were a fulfillment of this learning liturgy, right? From mini computers to turtles, to LOGO, to Scratch, to Fab Labs. And again, I went through this very fast, very briefly, but when you go through the paper, we slow it down, we talk about it in a very different kind of way. The key point here is that Constructionism 3.0, and Sherry and I were playing with this concept of objects to make and think with together. So we're going from objects to think with, together, and then you're in the Fab Lab, you have objects to think and make with together globally. Now, one of the things that happens when Fab Labs goes from theory to practice, Paulo Blankenstein is one of the leading scholars when he talked about digital fabrication in spaces. And when in 2013, he said what Logo did for geometry and programming, bringing complex math skills to the reach of children, fabrication labs can do the same thing for designing engineering. But once he went into the classrooms and began watching the observations, he saw there's the same traditional teaching methods going on. And he called this the key change syndrome. So in his mind, it was good for engagement, but it was too big of a reward for such a small effort because there's no computation and no higher level thinking and the other things that you can get out of a fab lab. So the issue is this notion of Taylorism, which is the neoliberal education reform kind of way of thinking about this. And it's, the emphasis is on standardized tests. And this is in direct opposition to Freire's notion of banking concept, right? And he calls this an oppressive classroom dynamic. And again, in the paper, we have the longer version of this quote, but it's a devastating quote on Taylorism. It's one of the best quotes I've seen describing the process. And he talks about teachers teach and the students are taught. Teachers know everything and the students know nothing. The teacher is the subject of the learning process while the students are the mere object. The Danish Lab School, Smith et al., they also did some looking at classroom teachers with Fab Lab tools. And they came up with a very similar conclusion that teachers were still using these tools in the same way that they have always used the tools. And so out of this, though, comes this notion of the Fab Lab EU partnership, which is a group of 4 EU countries, and they're trying to create a common methodology principles for digital fabrication, starting in primary and secondary schools. So this was the first attempt to say, okay, digital fabrication, constructionism, Fab Lab, let's try to pull it together. But again, the problem still is that people teach it in traditional ways. So we try to identify some best practices that are out there. One of the first one we talk about is the work at Tufts and Byers. She was a student of Papler, and she's co-designed Scratch Junior with Resnick. And one of the things she was focusing on is this notion of social emotional learning. And social emotional learning is a key skill set in early childhood development. And so she came up with this model, the technical development framework. I won't go into it in detail, but it has 6 C's and 6 personal behaviors. But the key point here is that rooted in constructional principles, her case studies in the United States and Denmark confirm the positive impact of Fab tools on enhancing SEL in pre-K settings. Why this is important is that it moves the K through 12 to PK, childhood education. And childhood education is a big thing now because people are understanding that you have to have skill sets before you come into kindergarten. And this might be a possible approach to getting people there. Then a team of construction scholars at Finland did the same thing. Then we have the Fab pedagogy. Now I want you to read the whole paper to get the whole sense of this. But at the end, we're talking about how democratized access, education leapfrogging, and looking at how to reimagine schools and looking at Fab issues. I really suggest you go to the website, pull down the paper. Tomorrow, Peter and I are talking about this in greater detail as well as part of another project. So we'll be able to slow down and talk about this. Very thick, very lot to get through, but it's compact and a lot of stuff is in there. Thank you.
Thank you very much for that, Melvin, for this tour de force and introduction into a quite complex and still evolving, very interesting issue. Thank you so much. And the question regarding time, I would ask people to ask questions in the chat so Melvin can answer there. And please, Melvin, stop sharing your screen because the next one up is Evelina. I've seen you coming in, Evelina. Are you there? So please open up your camera and start your presentation on iCanRobots, a very practical implementation of what we just heard about.
Share. So I hope you see my screen now.
It's all white.
All white.
See a white screen.
Not on my side.
You're sure you're sharing the right window?
Oh, I see the right window. Yeah, it might be. Okay. I think I know what it might be, but let me. Okay, stop sharing and share another. Where is this? My mouse disappeared. I think my computer is just too overwhelmed.
It would be very heavy.
Yeah. Let me try that. Hard close, one of the. I think almost everything is frozen right now on my computer, but maybe I can at least start talking. Stop sharing, and then I'll share rather PDF than the presentation. Usually, it sometimes works better. It's the backup mode. Do you see my presentation now?
Yes.
Okay, great. So I think that was basically a very upset state. Really, I'm going to present a class that we did. We call it iCanRobots, and it does exactly that, what all this predecessor have been working on to do. We want to do it active, holistic, and inclusive STEM education, and that really has the power to empower communities and children. And so you hear me, and probably you see my video right now, but I like to introduce my co-authors, Christian Faubel. And he's basically the one who developed this concept with the robots who dance on overhead projectors, and is artist and electrical engineer. And then also Katia von Roth, and she's artistic researcher, and is really about space and enabling communities. And we were also very lucky for this particular project to get the support for the Deutsche Telekom Stiftung, which has the name Yes, I Can. So that just the money who covered the whole thing, but also a lot of intellectual support. And very, very critical for the project to work was the Alles wird schön Gallery. And that's led by Jürgen Halvig. And that's a community space where kids can do arts mostly, but also grown-ups. And it's really trying to reach out, and it's a very well-connected place in the neighborhood, such that we could really, what we aimed for with this project is not to just reach other professors' children and nerds like we are, which usually happens when we work in Fab Labs, but really go reach everywhere who just happens to live in that neighborhood. And why we're going to present this project here? I was struck when I saw Hamburg in that year when we did the workshop. A few months later, Hamburg became part of the FAB, became a FAB city, where several at that point, also the full stack was presented, how different about exchanging data instead of resources, exchanging know-how. But for learning, it's clearly there is the real for STEAM education, learning by doing, how to learn. But there was really very little concrete what it means, how to achieve those goals, and just some kind of promise, new forms of learning. And I said, what I also do is like educational research. And one thing in educational research is really the design, bringing the design process of a class into the foreground and really see how do we do a holistic STEM education? How do we empower communities and children? How do we learn through doing? And that's why I'm going to present some details of the class that we did, and then try to go on this design-based research method where I try to explain the educational design and why we think we do achieve what we promising to achieve. So, so what is it? Yeah, instead of new, we propose basically you can look at the ICANN robots class as a feasible prototype for like great education. Let's shorten it up. So. Ordered concepts of the class that we did. So on the picture which points 1.5, that's the scheme for the robot. Below it you see the components, and that's also a worksheet that the kids use. So we did a lot of theoretical stuff, what those components do, which was pretty frontal, but the most important thing is that they really did take the sets and work together to, are you still seeing my screen? I had a blackout here. Okay, good. So, and what you see in the other picture, which is with 1.6, is basically kids worked in pairs to make such a robot. So each pair of kids made 2 robots. One was holding the components, the other one was following just the sketch and trying to build a robot. At the end, 2.5 is the basic robot. And they usually, and one great thing about learning by doing is there are mistakes. It's not perfect world. So we then can have tools such that the kids can experiment and check, does the robot work? They can, but also we need the overhead reactor because the solar cell needs a lot of energy for the robot to move. And then we have down there also a little bit we see 2.5. Also, with overhead projector, we can put a pencil on the robot and just let it move around and see what kind of patterns it does. So we can examine what's the electronics that goes there with voltmeter, and also the behavioral, the overt behavior of the robot. So, and that was another important concept of the class, is to do the same thing from many different perspectives, do the artwork, do the sort of scientific measuring, very precise work, do observe behavior by tracing it, scale it up. So then another, but that was not, I think is in 3.5 and 3.4, you see like the kids that cannot see with those glasses except for a little bit of light, then they play robot. In one scenario, they follow commandos, and the other one is more like an autonomous robot where they just react to lights and give each other signals by holding hands. So that simulates a little bit like the autonomous robot, which we try to understand, like what can, on a scientific level, what behavior, how can behavior emerge from simple components. And what we also work quite a lot that you see in the top picture is 1.2, but that was something, we created a network. We started with everybody introducing themselves with a little card, and then connecting with Rob, who is who and where we see connections. And we did that throughout the work. So we started with quite plain wall, but just using the entire room to see our connections and make them more permanent. But also everything, the great thing is with having to work with the overhead reactor, all the nodes we did, all the experiences we created during those 5 days, they can be summed up on the walls and recalled on the overhead reactor and scaled up anytime. So having this repository physically there, and the growing connection presented as well was, and we did a little bit of science. So we see here the mathematics stuff behind it. And an important point is children also learn to present their work. We invited guests at the very end. And we'll skip the scientific part.
Thank you so much, Evelina, for a great presentation. Luckily, We've got your paper in the proceedings, and this is the first time of almost 10 years of Fab Lab research papers that we actually were able to publish the papers before the presentations. So everybody
Well,
can
great job. It's well organized and
the colleagues
amazing how smoothly it works.
can find the link to the paper in the chat box. So if you would please stop sharing your screen,
Yeah.
because I'm going to ask Thomas Poulain. Bonsoir, Thomas.
Bonsoir. Hi, everybody.
You'll be presenting in English. Thank you. Your paper is in French, so we're glad to have at least one French paper in a conference that is hosted in Canada. Please, Thomas, take the floor and tell us about what you did in your study, particularly in reference to Quebec.
Yes, thank you very much. So just for a little bit of context, I work in a public library as in French it's called animateur spécialisé, which is basically Fab educator. I wrote the paper a little bit for myself to figure out what exactly is my job, because nobody taught me how to do it, and nobody know exactly how to do it, because it was among the first project in Quebec. So now I did it as part of a master degree to become a librarian. I don't have any background in information science or fabrication, so I have an outsider view of both. And I was trying to answer the question, how do we create knowledge in the lab situated in library, specifically knowledge about digital literacy, digital skill. It's a review of literature. So we went through the different sources talking about knowledge creation. So first of all, we framed different concepts to figure out what exactly we talked about. So the concept of creative laboratory is the one we use to frame a broad range of what we call in the library third places. So it's a new way to conceptualize the interaction with the user in the library, and makerspace, hackerspace, media lab. So all those different kind of concepts for creating in the library are used in this concept. It's also the concept that is used by the Ministry of Education in Quebec. So they did a lot of work to build a framework based on constructivist and constructionist theories that Melvin presented earlier. The other key concept that we framed was the digital literacy. So there's if we resume simply what it is, it's being able to use a tool you need to receive or send a message. More specifically, being able to use, create, make information, culture, object with the tool at your disposal. And part of this digital literacy, we find that it's fit with what we define as maker culture. So the set of aptitude and attitude to learn how to make and use those technology. And a concept that was used on in a text about the Quebec education system, hacker ethic, we found that it's very, very useful to frame the kind of mindset that we want to foster in the libraries lab. So it's really a philosophy of sharing, openness, decentralization, and experimentation with the tools at your disposal in order to improve the world, so around you. This concept of digital literacy encompass also the skill you need to learn the skill to make. So learning to learn is really part of this skill set that we want to try to build. So we split the paper into three main way knowledge are created in the labs situated in the libraries. So by the staff, by the population, the users, and by collaboration between the stakeholders. So what we found is that most of the staff working in the library don't have prior skill. And according to a survey conducted by Orton 2 years ago, most of them don't have more than half their time dedicated to making or this kind of project. So that become a big issue in the training, in the professional continuous training of the staff, especially here in Quebec. We found the same kind of reality. So we had a lot of financing to buy equipment, start project, but freeing staff, freeing time, recruiting staff, having the budget to finance, and also giving them the space to learn and train themselves, it's still something lacking. So we notice an increase in the offering of continuous formation, continuous training for the library staff about making maker culture, but it's still behind what is needed both here in Quebec and also more generally in the literature. Also, there's a kind of redefinition of what the staff are doing in the library. One of the authors, Williams and Willett, talk about frontier works. It's really asking the question about what we do and what we need to know to do that. So really asking the question of what is the role of the staff in the space. And this is not yet clear for everybody. That there's not a consensus emerging, but we need to take an approach where we facilitate learning. So librarians tend to view themselves as provider of information, as the kind of a delivery mechanism for knowledge and information. And we really need to take a step back from this view and really see ourselves as creating spaces where learning can occur in the kind of approach Melvin talked about. So the constructivism approach where you learn by mental process, by engaging the learner, and also with the approach of Papert, where you you actualize this learning by engaging in personally significant activity. So that way you anchor your learning in reality and you can share it with other person. And in the library, there's a bunch of practice we deploy inspired by this kind of framework, whether it's Omago, hanging out, messing around, geeking out, do it yourself, challenge-based. So we actualize this kind of learning without necessarily having the reflection where it's coming from, and it's a little bit more of an instinctual practice that we figure out, but there's no unifying way of teaching or approach. And we often find in libraries that this way of learning is not yet integrated in all of our activities, but we are aware of it, especially in Quebec, both in the school system and in the public library system. This kind of approach is what we try to put forward and what we try to offer in our space. But the lack of staff, the lack of time to build this kind of framework, this kind of environment is not yet there for everybody. Here in the library where I work, we are especially lucky to have full-time staff to take care of the equipment, build the community, but it's not the case everywhere. And it's something that the people in charge need to understand. You need to make those spaces live through the building of community, through a vision of learning where you put the learner in the center and in control of his learning process. Especially in school, library school can be used to really build more democratic classroom, have more open space where students can collaborate with each other, help each other learning, and work on common projects. At the core of this, the staff need to foster collaboration between the different stakeholders within the institution, within the libraries, whether it's public, academic, or in the school system, but also with all the stakeholders in the community that use the service and that could benefit from the service or that could contribute to the lab, especially in school. The staff in the library makerspace need to foster this kind of makers culture, more than just showing how to use a tool and what they can do. It's really the role of the staff to engage a different teacher about what we can and how we can use this culture in different way of learning. That was the clock.
Thank you so much, Thomas. And like for everyone else, we're short of time, but we very appreciate your contribution to that session tonight. The link to your full paper in French is again available for les connaisseurs de l'éducation in the chat. And I'd like to ask Naldi, hello, to come up next.
Hi. Great. I'm going to share the presentation. Yes. Hi. Tell me, please, if you can see my screen.
Yes, very nice. Full screen.
Okay. So our paper is related to visual impairment student inclusion using digital fabrication technologies. So we try to share some collaborative development for chemistry learning support tools. So our three base outputs were regarding 3D modeling, a 3D modeling representation, or some concepts that we use when we learn chemistry, okay? So we can develop then a physical prototype. Then it serves us to have enough information regarding the appropriate digital manufacturing technology that we can use for reproduce this kind of tools. And in the process, we have a lot of user testing feedback. So as one of our main outputs to develop a final prototype, okay? So our first stage was exploratory processes. We're trying to build an accessible tool. That means a tool that could be used for those that are the normal vision students and the ones that have blind or low vision impairment. So the idea was to first start with exploratory processes, so we can discover the different teaching methodologies and tools that the common teachers apply when they deliver the different topics related with chemical elements. So we register the different expected outcomes that the teacher could give us different kind of information regarding those outputs. So we also grab information regarding the different tools and methodologies, the different graphics, software, exercise, and at the end we found that for the teaching process, most of them use different kind of tools that were based in the common periodic table that we all, I'm sure all of us know. So based on that, we create a 3D model that we can represent the chemical elements and link this physical and this model with a specific concept that we all know when we start learning chemistry, that it's the atom. So we want to reflect in this tool with this concept, so we can understand that the atoms and the electrons goes around a specific shelf. So the idea was to develop that kind of model, and then we can, based on that, deliver a specific physical product that help us to learn and understand the different relationship between chemistry elements. So the second interaction, the validation process of this tool was related with trying to understand or validate if our idea of this 3D modeling process were helpful in order to serve as a potential teaching process and tool. So we wanted to validate the 4 different components. If you can see here, we have a baseboard, we have some spheres that contain specific information regarding the elements. We have 3D printing labels for the subshells that have a specific information. The spheres have a specific information regarding the elements. We practically, based on information contained on the periodic table, we developed this model. So we wanted to first to validate if this kind of gaming tool could be helpful in order to understand the electronic configuration, the electrons configuration, sorry, of the elements. So we tested with teachers, first with the ones with normal vision teachers, from high school and university teachers. We separate we validate the model, but we also validate the flow in terms of how we can build a specific methodology to use this tool in order to learn the electrons configuration for chemical elements and understand the different characteristics that some elements share because of the how they are how they have a specific electron configuration. Okay, we use as a base the experimental study that was undertook by Barczyk, that is related with the embossed characters of Braille alphabet. They already prove specific characteristics or features in terms of the dots, the Braille dots. So we use that information to emboss the Braille alphabet into the spheres to drop to contain information regarding the chemical elements. So at the first validation, at the second iteration, the validation processes, after we obtain 82% of the teachers that give us positive feedback regarding the model, so we test the spheres that it is going to contain the information regarding the elements, so we can the teacher could explain further the different characteristics of the electronic configuration. So for this iteration, we test the quantity of information that we could drop into the spheres. So we tested with blind teacher and blind people that could help us to understand if there was it was too much information or it was okay, and they also test the characteristics of the dots, of the Braille dots. So we ask a lot of information. We tested the different characteristics regarding the different 3D printing that we have. We use FDM printing technology. So we test the quantity of information, and we discovered the first things that we discovered here in this second validation was that we needed to place a Z-axis point of reference because of the form, because it was a sphere. They needed a point of reference in the Z-axis. So that was the first feedback. And then the clockwise reading needed also L-shape or some kind of reference. So we get feedback in order to include this L-shaped figure into the sphere so they can read it clockwise. In terms of the technology, we have a little feedback regarding some kind of wrinkles that they notice. Okay, so we understood that for the other testing, we have to prove the different qualities of to change some kind of parameters in terms of the 3D printing. So the idea it was to prove that the reference in the Z-axis and the L-shaped form in order to guide the clockwise reading could be helpful, and to prove the quality of the 3D printing. So the third stage was to receive this kind of feedback So we tested, we prototype, we have 5 prototypes. So we test resolutions in terms of the FDM and also in terms of SLA 3D printing. Okay, so in terms of the resolution for the FDM, we used 120 microns, 190 and 90 microns in different. The first one, it was with PLAM, and the other 2 were with ABS. So we test the material, but also the resolution that we have. And then we try also with SLA. Here, we have to highlight that for the SL resin to print it, we can fully print it. That means to print all the volume of the sphere, and to reduce the time, we could add a specific form for the printing process. So we have to reproduce the sphere with 2 holes in order to reduce the time for the printing. And we wanted to test if there was a difference, if we have a specific quality differences in terms of this kind of 3D printing process. What we obtain is, even though the SLA have more quality, obviously, and they reduce the wrinkles, the wrinkles that appear because of the printing when we use FDM. In terms of the cost and in terms of the quality, we can use FDM 3D printing with ABS in a medium resolution and standard resolution, and it's not going to interfere a lot with the reading process. So the cost will be less, even though the SLA it turns to be to present less difficulty in terms of the reading. The FDM could be more useful in terms of the investments. That's all. Thank you.
Thank you, Naldi, for a very interesting combination of making and education, and this idea to actually cater for the blind. Thank you very much for this very interesting presentation. That's the end of the first half of this session on learning, and we're swiftly moving on to innovation. And I'd like to call up the first paper, which is on makerspaces and startup entrepreneurs. And I've seen Ziti Asma somewhere in the list of participants. So if you want to come up and talk about your research, please.
Hi, everyone. First, I would like to share my screen. Can you hear my voice clearly?
Absolutely.
Okay, thank you. Me asusta.
Se despertó,
Your screen.
Quiere picar, ¿no?
Voy a dar porque ya está. Vamos a pasar primero aquí. ¿Cuál es mi celular? ¿Cuál es mi pequeño tesorito?
So, my presentation is okay, hopefully.
Yes, we can see it.
So, okay. Hi, everyone. My name is Siti Asma Juso. I am now presenting from Malaysia. Probably I'm the farthest from Montreal right now. And then it is actually 2 a.m. in the morning on Wednesday in Malaysia time. Actually, I'm trying to not to fall into a sleep. So without further ado, I would like to present my short paper titled A Model Makerspace for Digital and Creative Startup Entrepreneurs. For a short introduction, I would like to highlight the challenges faced by small and medium companies all over the world due to the pandemic, and also highlight highly impacted by the acceleration of technologies that disrupt many industries. So as for the motivation, we know that makerspaces and Fab Labs are known for their achievement in producing many successful innovators and startup companies. For that reason, I am proposing a solution of using the platform as one of the solution to help small companies, especially startups. Unfortunately, currently, there are no specific open source modules that cater to all target groups. And on the other hand, we also know that the program and module in Makerspaces Fab Lab are unique to the cultures, community, and focus groups. That means not all open source modules out there can be adapted 100% to any specific places. For that reason, we are developing an initial model for a makerspace, particularly for this work, which is targeted to startup entrepreneurs in the creative and digital industries. So the main goal of this work is to develop a model makerspace for startups in digital and creative industries. There were two objectives. The first one is to evaluate important factors that can assist the product design and development. And the second one is to measure the factors on related to entrepreneurship readiness of the participants. So these are the demographic data of the 50 participants, which were the university students who went through the same training program in a makerspace located in my university named MakerLab UITM. So these students are actually from different backgrounds, but they are not from engineering related fields. So there were two dominant groups of the participants, as you can see in figure 1 here. So there are 24 students from computer science and 18 students from art and design backgrounds. The rest are from applied sciences faculties. And also for the information, the number of female and male participants in this study are equal. In figure 2 here, I would like to show that the current status of the respondent, which is already completed their training in MakerLab. So 29 of them are still students, and 13 of them are now working with companies, 7 of them are self-employed, and only 1 are still looking for a job. So for the methods, we use the question was created by Google Form, and the answer of the survey were analyzed using the SPSS and other common plotting softwares in order to compute the mean percentage and the total count. Okay, so now I would like to present the results. So overall participant satisfaction based on the result, it shows that the respondents were very satisfied during the training, and they are highly believe that MakerLab is the right place for the student to start their entrepreneurial journey. And so later in the next page, so I'm going to present 3 main factors that we measure in this study. The first one is the training program, and module that we use in the training. And the second one is the facilities, equipment and tools. And the final one is the management and support of the MakerLab to the participants. So, okay, the first factor, which is the program and modules that we use in the training. So based on this results, most of the respondents think that the training made them more creative and innovative. So particularly, we can see in figure 3 here that 76% of the respondents agree that they learned the product development and design during that training. In addition, there is also support a question for that program and module, where the respondent also learn other important soft skills which are useful for entrepreneurs, as shown in figure 4 here. So it shows that here 100% of the participants agreed. They actually learned the design thinking during the training, and also other type of soft skills. Therefore, actually, we agree that the program and module that we use for the training play important role to assist the participant in developing their products, as well as preparing essential skill for them to become entrepreneurs. However, as you can see in figure 5 here, it shows only one respondent embarked as an entrepreneur. And 4 respondents stated they are ready, but the rest, which is 90% of them, saying that they understand the process of becoming entrepreneurs, but actually this response somehow in line with the current status of the respondents, which are most of them are actually still completing their first degree. So the next factor is facilities and equipment in MakerLab. So here you can see that we use this 4-question as a Likert scale. Here you can see the standard deviation is very low, and then the result shows that highly likely the respondent show very positive or highly rated all these questions. So what we can extract here, that the respondent highly rated the facilities and the equipment used in the MakerLab. The facilities and those equipment were very important for them to develop their product, and the workspace conduciveness helped them to generate creative ideas. And the last one, they also believe that using those equipment make them able to become entrepreneurs. So there is also supported question. So here in figure 6, it shows specific equipment or tool that were used by the participants during their training. So you can see that 3D printers were used by all of them, and other tools were being used by less than half of them. When asking the respondent or the participant on the opinion which facilities that can help them to become entrepreneurs, and the most highly rated go to the high specification of computers and softwares. So the final factors is the management and support. So we use 3 questions to get the mean here. So based on this table, as you can see, the question 1 showing that the respondents are very satisfied with their management. However, based on question 2 and question 3, it shows that the support provided both internal, such as here, the internal, what I mean is here is space, facilities, module that we prepare for them, and also a support, external support, which we give them exposure to participate with the industry, government agencies. Those supports are not enough to make them start their business straight away after completing the training. So as supporting question, we also ask about the type of support that they received during the training, and also the ranking of the equipment or the facilities that the most useful for them. So more than 90% of the respondents stated that they got support in terms of free materials, workspace, and mentoring, and the least support they got was funding. So in addition, the table 5 shows the ranking here. So the first one, as you can see, the first rank is equipment, followed by mentoring, and the last one is the free materials. So so this is actually external support, which is, I think, is not important and doesn't contribute much. And finally, this is the final slide that I would like to highlight. So basically, the model that we have here is actually suitable for the design, for the user to produce design and product development. And then, however, they are not the entrepreneurship ready. Is actually they actually believe that Makerspace is suitable for their entrepreneurial journey. However, the data shows that only 9% of them straight away become entrepreneurs later. But as you can see, the input data might be the limitation because most of them are still students. So that for our future works, we think that this model maker space can be proposed to experimentally implemented in a startup incubator, which are the users are ready to become entrepreneurs. With all that, I would like to thank you everyone and acknowledge the funding and support from my university. Thank you again.
Thank you so much, Siti. Thank you for staying up so late for us to present your work. Really interesting, and a lot of work to do there, obviously, to turn students into entrepreneurs, not only in Maker Labs. I think that's a big issue and an interesting development all around the globe. Thank you so much for being with us here. And I'm calling the next presentation, which brings us to Europe. It's about the Syscode European project. And Marion, you're going to present your findings.
Yes, hi everyone. I'm sharing the screen.
Yes, we can see it.
Okay, full screen now.
Yes.
Okay. So yes, I'm presenting today this paper, Co-Creating Social and Sustainable Innovation in Makerspace and Fab Lab, Listen and Learn from the Syscode European project. It's a work that we have done with other colleagues of the project, which are not here today because of holiday, but they really are happy that we can bring this knowledge and share what we have done in Syscode with the Fab Lab community. So there is Carla Sedini from Polyfactory, Asger Rasmussen from Maker in Copenhagen, and Laura Cipriani for Polyfactory, and I am Marion Riel from Fab Lab Barcelona. So I will first introduce a bit Syscode. Syscode, the acronym means Co-Design for Society in Innovation and Science. It's a EU-funded project aimed at stimulating the use of co-creation by applying a bottom-up approach and really engaging many stakeholders in design-driven innovation process. Its aim is to pollinate responsible research and innovation practice in science, technology, and innovation policy. So quite big policy level, EU level at the beginning, and we try to operationalize it locally in some territory. And also with all the partners of the project, we came with a definition of co-creation first, because there was many interpretation of the word at the beginning of project. So co-creation has been interpreted as a non-linear process that involves multiple actors and stakeholders in the ideation, implementation, and assessment of products, service, policy, and system, with the aim of improving their efficiency, effectiveness, and mostly to satisfy the people who take part in the process. So there was many output from the project, and I will focus today on the experimentation and specifically on the role of the Fab Labs that participate in the project. So the experimentation in total is the creation of 10 co-creation labs, co-producing, co-designing answer and solution to specific societal challenge that come from their local context for a real territorial needs. We came with some methods, tools, and a methodological framework to guide the experimentation, but each lab was quite autonomous and really can customize a bit the journey of co-creation that it was happening. This model was inspired by the experiential learning model of Kolb's and an iterative design process of 4 steps, which is quite classic when we talk about design process. We start with analyzing the concept, we reframe some the problems, we envision alternative, and we develop and prototype in an iterative way. So each co-creation lab lasts more than 18 months, so it's quite long as a process. Here you can see the different labs. There is 3 types of labs. There is the living labs, the Fab Labs, and Science Center and Museum. So in blue, you have the 3 Fab Labs that I mentioned: Maker in Copenhagen, Polyfactory in Milano, and Fab Lab Barcelona in Spain. So for this specific paper, we choose to make like a comparative analysis of the co-creation process of the Fab Labs, and we use the base of the analysis was a model that was creating in the project, which is quite complex and I won't detail today, but we simplify it and try to analyze the cases at 3 different levels. So the micro level consists in analyzing co-creation practice during this co-creation project. So who were involved, what tools do we use, etc. There is the meso level, and here we look at the capacity in terms of co-creation at the lab level. And the macro level is about talking about the ecosystem level and looking at more the dynamic in the territory, and also depending on the challenge, also different layer of policies. So briefly, in Copenhagen, what happened is the name of the project was People, mean plastic in, plastic out. They develop a small-scale ecosystem developed for designer, company, and maker working with the circular economy and the recycling of plastic in Copenhagen. So what you can see here is that they develop a different type of products, materials based on recycled plastic. You can, it's a bit inspired of precious plastic, but you see that there is also really nice quality, product. They really focus on the planche that you can see with these different colors at the center. And the idea here was really to create an ecosystem. So during all the projects, they connect with the generator of waste, the provider of the waste, the developer of solution, the designer of the Fab Lab, and also the consumer, and try really to align the stakeholder in Copenhagen to make this possible from the labs level. The Polyfactory case is named Body Sound, and here is completely different. Is still in the healthcare sector. They look at improving the movement of children that was affected by cerebral palsy, which is a quite rare disease. And they develop a system for physical reactivation. So it's a video game where the child can perform choreography and transform it into a melody. So it's quite playful, and with that aim really to activate a new movement for people that have some difficulty with that. And they work with the patients, with the child, the family, the therapists, some health experts to really adapt the software characteristic and to make really user testing for having this this software working and test this concept. The last case is Remix El Barrio in Fab Lab Barcelona. So this is about a collective of food waste material designer promoting and featuring emerging local ecosystem for the crafting and microfabrication with food waste. So here we explore in Poblenou, the district, one of the districts of Barcelona, and we look with restaurants, a local association, cafe, a local designer, and we look at what is the food waste there and what we could do there in this specific area, what's already happened. And we focus really on how we can craft, we can create products from waste, food waste. So many designers were exploring during this period how to do things with eggshell, with orange peel, and we had all the knowledge of Fab Textile, Fabric Academy, who followed also the designer and helped to build a really nice panel of products. So this is the free case, and in the paper after we discuss different elements. So briefly about sustainability. We explore this at 2 different levels. At the project level, so we can see in a simplified way the illustration here that compare the case with environmental, social, and economic, the classic model of sustainability. We can say that both the case of Remix El Barrio and the plastic in, plastic out start with this environmental burden coming out to solve a bit the problem with waste, and they explore at the social reality in the context and try to find new economic models to solve this. And of course, there is new solution, but also many difficulties on that. Bodison, on the contrary, is more slightly more on the social side. Beyond the sustainability of the project itself, that could be discussed really for a long time, I think, we can say that one of the results is really to see co-creation as a potential to sustain also the Fab Lab, and in two ways. The fact that in all the case, the labs appear like a place, really a safe space for learning and knowledge cross-pollination, where there is really an emergence of creativity to do innovation that's already quite present in Fab Labs. And there is also new series of services and also form of collaboration with the local stakeholders that could be developed from eco-social reality to healthcare system. Yeah, I can just finish maybe with this slide, and I think it's really worth every people in interest in co-creation to look at the results of the Syscode project, because really for the Fab Lab is not just the post-it approach with design method, it's really stronger as approach, and it's really about stakeholder engagement. It helps to think about how to look for organizational transformation. It's also guiding dissemination practice and how we can connect with the policy making approach, and how labs can be like this interface between policymaker and a citizen-driven approach. Yeah, that's it. I have too many slides. Sorry. And there is really many results. I really encourage you to go on the website to look at this. Thanks for the...
Thank you, Marion. More details are certainly in the paper for you to read through the link that Cindy has gratefully put into the chat. Thank you very much, Marion, for sharing your experiences there, for bringing up again that topic of connecting making and policy making, which we know from Google searches that if we are searching for making, we get a lot of results on policy making. So we really need to make that connection. Thank you very much, Marion, for that input. I'm moving on to a healthcare innovation project from Germany, and I think I've got Alessandra presenting that.
Yes, I'm presenting it together with Paula, my colleague. I will share my screen now.
Yes, we can see it.
That's nice.
Full screen now.
You can still see it?
Yes, full screen. Thank you.
You're welcome. Okay, I will give the word to my colleague, Paula.
Hi, I hope you can hear me.
Yes.
So, yeah, I am on another computer, so my name is Paula Janneke, and yeah, I'm happy to present the first part of our paper together with Alessandra. And as part of the project Macopedics, we were working on an open source approach where we developed a digital fabricated monitoring system for diabetic foot. And for this, we are working together with the Fab Lab Camp Lindford and the University Rhein-Waal and medical supply store called Bodai. And next page, here you have some information about the matrix within this company, and together with the university and partners, we are working on the project. So Macopedics is motivated by the lack of digitally manufactured orthopedic devices available as open source hardware, and the project consists of 3 stages. So the first was to create an individualized handle of a forearm crutch. The second one is the one we will present here. And the third one will be about an open dynamic handoff process. So Without losing too much time, I will introduce you in the field of orthopedics, and especially a disease called the Charcot foot. So the Charcot foot is a possible consequence of diabetes. It appears in the foot, and because of fragile bones, they can break easily and ulcers can appear. So it will affect the sensibility of patients because the nerves getting injured. And the foot will be treated either with a total contact cast or an ankle foot orthosis. And it's most important to reduce the pressure points and don't have big temperature changes. Otherwise, it could lead to destruction up to amputation. So challenges for the orthopedic technicians are the missing sensitivity. So they can't get a proper feedback if the orthosis fits or if there are pressure points. And it also is also difficult for the patient to know when to go to the doctor or to the technician. Furthermore, a lot of patients don't have a good compliance wearing of orthosis, so they think it's not necessary to wear it all the time. And next page. Because of these challenges, we thought about a sensor-based insole, embedded in the orthosis as monitoring and feedback system with pressure and temperature sensors. So there are some novelties in this project. First one is the co-creation process with an interdisciplinary team to share all expertise for the development of the system. The second one is the combination of conventional orthopedic work and digital manufacturing processes. Here's the goal to find a way for an easy implementation of the digital processes in the workshops. And furthermore, to have individual solutions because every foot is different, especially in this disease, custom-made solution is necessary. So the last but also very important point is the embedding of an insole inside the orthosis, because existing solutions have not been put on top of the orthosis, and not inside. So let's go over to the innovation process. So the project follows the approach of a new innovation process. Here we bring together technicians, patients, doctors, and makers. So here you can see the process we did to gain a quick and tangible output for prototyping. First, a design challenge was created together with the orthopedics in the workshop and to gain the requirements in this product backlog. So short design sprints, including design thinking and fabrication trials were done. And due to this concept, various versions of a sensor-based insole were developed and fixed in time boxes of 1 or 2 weeks. And yeah, with this, we go on with the prototyping to Alessandra.
Yeah, before prototyping, the requirements for the system were defined in collaboration with the medical supply store. Different sensor-based insole prototypes, as shown here, were developed and tested using various digital fabrication techniques to enable customization. And the customization process was realized using a 3D scan of a foot to design the sensors at the existing pressure peak areas. The first prototype of the pressure sensor insole, which is shown in figure 1, was made with the vinyl cutter from copper foil and EonTex, which is a semiconducting material. The advantage of this system is that it is flexible, thin, and light. However, the fabrication was not easy, and the output values of the sensors were not stable due to the slight stiffness caused by the lamination. The second prototype in figure 2 was made with an embroidery machine, which sped up the manufacturing process. Nevertheless, the values of the sensors reached their maximum even at minimum load. This is due to the fact that not only the selected semiconducting material, but also the size of the pressure sensors has an impact on the force sensitivity range of the sensors. For this reason, we decided to create prototype 3 and 4. And it was also mandatory that the sensors do not cause any additional pressure points on the foot. So everything had to be flat, even, which is why the commercial sensors in figure 3 and 5 were embedded. Both prototypes in figure 3 and 4 had sufficient force sensitive ranges and could be easily embedded in the orthosis. However, the third prototype does not offer the ability to resize the sensors. This means that using 8 sensors with fixed sizes may not be sufficient for some patients. So a process to easily integrate more sensors has to be developed. The matrix, on the other hand, provides area-wide measurements and can be customized by foot size. For the temperature sensors in figure 3, the laser cutter was used to create engravings to embed the sensors. For embedding, the system was divided into 2 control units to simplify the integration. The electronic box on the side of the knee, which is seen in figure 6 on the left side, is connected to the pressure and temperature insole system. The electronic box on the back of the foot consists of a buzzer and a pressure sensor to detect whether the orthosis is correctly applied. Due to the very difficult skin conditions of diabetics, no direct skin contact is allowed, so the system must be hidden inside the orthosis. The sensor-based insole is therefore inserted under the top layer of the diabetes adapted footbed. An interface and processing was also created for real-time visualization of temperature and pressure changes. As a conclusion, the innovation of a sensor-based insole system integrated into an orthosis offers a new additional care option for patients or doctors and orthopedic technicians. Daily monitoring of foot temperature and pressure can significantly reduce the occurrence of foot occlusions. Moreover, the high number of diabetics and the long duration of the disease have an impact on the healthcare system, which is why the development of this prototype could reduce the cost of treating diabetes. As mentioned before, individual fitting is inevitable and achieved through digital fabrication. The manufacturing process provides an easy integration in the medical supply store. However, additional training is required for the orthopedic technicians. The integration of digital processes can also lead to more efficient work hours, cost savings, and standardized manufacturing steps. As a result, the medical supply stores can either serve more patients or technicians have more time for the patients. It's also possible to transfer the system into treating other diseases. In the future, the health insurance companies and doctors could also benefit from the system, as the data would be visible to them, allowing them to track the progress and success of the treatment. Moreover, a rapid development of requirements with cooperation partners in an interdisciplinary team and good communication, even in difficult times as the corona, was achieved. Thank you very much for your attention.
Thank you very much. And we didn't rehearse that, but you were perfectly in time. Thank you for a very interesting contribution, very interesting application also of digital prototyping there. Congratulations to your work. If you would stop sharing your screen, then we can move on to our last guest tonight. This is also a healthcare related study from Mexico. Iruel, you're there. And you looked into the maker's response to COVID-19.
Yeah, thanks so much. Good afternoon. I don't know if you can listen to me. I'm sharing my screen. Okay. I'm going to share a little bit about my research from the last year. I've been studying how the small lab has been working the past year. So I'm going to show you a little bit. Well, as all you know, due to the health crisis caused by the COVID, our life changed radically. We saw our cities turn from places full of activity, joy, traffic, to empty places that we consider dangerous and which, at some points, the simple presence of our neighbors and friends generates mistrust, concerns, and uncertainty. In the case of Mexico, all this began at February 28, when the first confirmed case of the disease was presented. A 35-year-old man who had arrived to the country on a trip alerted the authorities. Almost a month later, with a multiple case present, the state of quarantine and confinement was decided, which came to force on March 23 of 2020. The situation looked unfavorable. Every day, the news reported the increase of contagion cases. Images were shown of full hospitals without available beds and without sufficient artificial ventilation equipment. People were seen improvising their personal protective equipment with what they had on hand due to the lack or not of a product, but also of information. In this context, that the population turned to helping wherever what way they could, and the maker community was also a very citizen manufacturer, laboratories did the same. Supporting with what they could, many of these labs replicate models of personal protective equipment that was available online for sale and in most cases for donation. In addition to this, there were specialized labs that, given the shortage of medical equipment, generated new proposals with what they have available. Proposals for valves for respirations, ventilation systems, and protective equipment for medical personnel, not to to mention a few examples. Over the months, the circumstances changes. The previously unknown disease began to take shape. Its life found in different materials were known, and the general contagion process was already shown with more efficient protection measures generated. This change in circumstances was also reflected in the activities carried out by the maker community, many of which could go unnoticed if a follow-up program that allow us to document it were not realized. Analyze and the future time model the behavior of this will help us know what to do in next pandemic or other problems. This motivated present investigation, in which the development of the behavior of small manufacturing laboratories in Mexico was investigated using ethnographic techniques. To do so, we created different we searched for the different open social networks, such Facebook and Instagram, for groups where manufacturing laboratories participate, regardless of the size, but they need to allow the people and the community to develop their own projects. In addition to this, the groups have to have at least 10,000 members, show activity at least every 2 days, and be in the range of action of the Mexico territory primarily. After scouring on this screen, it is discovered that only 4 groups in the social network Facebook meet the requirements, so they were used as a case study. All the publication and comments published in these 4 groups between January 1st and December 31 were collected, obtaining more than 1,000 new publications with an average of 2.7 interactions per publication that were analyzed. These publications were transcribed, ordered, and evaluated in terms of the content and subject, discarding commercial publication or with primarily offensive content. After this work, the information was grouped in 9 categories, keeping the date on which the original publication was made and grouped them by quarter. The categories are requests to help solve manufacturing problems, requests for advice on surface finishes, requests to create 3D models or to share them, sales of consumables, offer and request of courses of manufacturing, job application and offers, help selecting manufacturing equipment, and specific topics about COVID. I'm going to talk about this last one, the specific topics about COVID. As can be seen in the graphs, as a general view, the highest activity occurred in the second quarter of the year, changing the behavior of the groups at this point, according to the changes in the global circumstances of the pandemic. During the month of March, the most repeated topics of the forum were related to the manufacture of automatic respiration, valves, requesting volunteers and design groups to address the problem, emergency medical supplies, and donation of equipment. Doing an analysis crossing the situation to the country at the time in which the news marked the insufficiency of this respiratory hospital and the idea of healthy disease was the degree in which people had to stay in their homes, it is understandable that, in the best faith in the manufacturing group, if they want to address this problem by proposing solutions that range from the use of modified traditional medical devices such as ambulance resuscitators to the creation of devices that use a fish tank type air pumps as ventilators. However, in a short time, it was discovered that these devices could not only be inefficient, but several of them put a health risk of the patient in permanent damage. In the month of April, the topic changed, being the main ones, the personal protective equipment, the support for face shields, the manufacture of 3D print face masks, accessories to cover commercial face masks, the concern about porosity and nature of the polyethylene acid as material for manufacture of personal protective accessories, and the search for filaments with antiviral properties. During this month, the strategy changed to the use of face masks and personal protective equipment for people who had to go out to work or carry out their work. Keeping the campaign of safe distance, however, equipment such as face masks and plastic masks were very scarce and in many cases expensive. In no time, the massive manufacturer of face masks, another with the domestic manufacturer, allowed the reduction of the cost, which reflected during the month of May, in which the most addressed issues were adapters for face masks, children decoration for the mask, and the production of filters for household masks. Making a cross matrix between the specific issues of COVID-19 and the publication seeking support for the creation of distribution of these models, a strong correlation can be seen. We requested to share models being higher at this time, face mask supports, and masks as well as personal protective equipment were the number one. Donated by the manufacturing laboratories also shown that many of these were not dedicated to the creation of new projects, but only to the replication and distribution of existing models. This replication in large volume led to a temporary shortage of material and filaments, as has been seen, were highly consumed during the second quarter, gradually recovering from the third. However, with the pass of time, laboratories saw new ways to generate profits in the face of the closure of business and the economic reduction, barring the interest in the creation of deficiencies that respond to COVID. Toward the reproduction of products for retail sale. However, in this interest in creating personally and only one-time use the products for they are demanding right now training courses and increase this tendency to the fourth quarter of the 2020. Many more relationships are yet to be obtained. This work is still in progress, and it must be updated with the data of this year. So this research will continue all year long. In fact, we have found different insights that have been changing this year according to the 2020. So I am working right now and can only thank you for your time and your attention. Thank you very much. You are mute, Peter.
I'm muted. Yes, thank you, Iriel, for this very detailed insight into what the meaning of makers can be in a country like Mexico, and also the development of the various topics over time. Very interesting insights there. Ladies and gentlemen, we've come to the very end of this session on learning and innovation. I'd like to thank all the 8 panelists, or presenters rather, for their input tonight, or this afternoon, or this morning, or this night for some. Thank you all for your work. You've seen all the links coming along in the chat window. Thank you, Cindy, for putting those in there. They're all available also from the zenodo.org website if you key in the FAB16 tag. I don't want to hold you many longer here in this room. You might want to go to another workshop. You might have to pick up your kids. You might want to have a drink or go to sleep or have any other competent business to do. Cindy, do you have anything to add tonight?
No, but thank you to everyone. Fantastic papers. And thanks for keeping the time so well.
Thank you very much. Bye.
Thank you, everyone.